Venus is often called Earth's sister planet, nearly the same size, made of similar rocky material, born around the same time from the same swirling disk of dust and gas that built our entire solar system. And yet today it is one of the most hostile places imaginable. A surface hot enough to melt lead, crushing atmospheric pressure, clouds made of sulfuric acid. For decades, scientists have asked a haunting question: was it always this way? And a strange new study adds an even stranger twist. What if some of Earth's own life made it there first? In 1982, the Soviet Venera 13 probe became one of the only spacecraft to ever photograph Venus's surface directly. Built to withstand the planet's crushing heat and pressure, it lasted just 2 hours before failing completely. Those images and decades of subsequent research painted a clear picture. Modern Venus is no place for life. Not on the surface at nearly 900 degrees Fahrenheit, not in the atmosphere below, thick with corrosive acid. But scientists began looking higher, roughly 48 to 70 kilometers above Venus's surface. Within its cloud layers, conditions change dramatically. Temperatures and pressures there are far closer to what we experience on Earth. Still acidic, still dry, still hostile by any reasonable standard, but survivable perhaps for short periods, at least for the right kind of organism. That possibility led researchers from Arizona State University, Johns Hopkins University's Applied Physics Laboratory, and Sandia National Laboratories to ask a different kind of question. Not whether Venus was ever habitable on its own, but whether life from Earth could have reached it, carried there by the same violent process that has long been proposed to explain how life might move between Mars and Earth. This process is called panspermia, the idea that life or its building blocks can travel between worlds embedded in rock, carried by asteroid or comet impacts. A sufficiently powerful impact on ancient Earth could have blasted surface material into space. Some of those fragments, over millions of years, may have eventually crossed paths with Venus. The researchers' estimate is striking, if modest. Roughly 100 cells from Earth could be dispersed into Venus's clouds every year through this process. Extrapolated across 1 billion years of Earth's geological history, that adds up to roughly 20 billion cells potentially delivered to Venus's atmosphere over time. The researchers are careful to note significant uncertainties. Heat may penetrate deeper into falling rock fragments than their models assume. Real meteor fragmentation is likely far more chaotic than any simulation can fully capture. And even if microbial cells did reach Venus's clouds, nobody knows how many would actually survive the journey, or for how long they could persist once there. Complicating the broader picture, another recent study led by Teresa Constantino at the University of Cambridge found that Venus's interior appears extremely dry. Analysis of volcanic gases revealed water content of at most 6%, suggesting Venus may never have had the water-rich mantle necessary to sustain long-lived oceans. This supports the idea that Venus was parched from the very beginning, rather than once resembling early Earth. NASA's upcoming Da Vinci mission may help resolve part of this debate, sampling Venus's atmosphere directly and studying its chemistry during a planned descent through the clouds, potentially offering the clearest picture yet of what's really happening in that temperate cloud layer. Venus remains too harsh for easy hope, but it sits close enough that Earth, across billions of years of cosmic violence, may have quietly thrown life its way, and we may not know the answer until we look again.